Hello and welcome to Nomira Virtuals. This is your brother Edozio Nochukunos Emmanuel. Today I'm going to be teaching us a very important topic which will help us in conducting our simple experiments. It will start from weighing substances like solid solutes and liquid solutes and how we dissolve it in solvent, particularly distilled water, to obtain concentration of that particular solute. So let's go to the class and see what we have for today. Hello and welcome to Nomira Virtual Special Class. This is a chemistry topic, percentage composition. Percentage composition is about finding the percentage of a solute in a solution. In other words, we can say this is a type of concentration, of course. But here we are going to be looking at percentage composition in two ways. The first one is percentage composition by volume. The next one is percentage composition by mass. Okay, these two actually have the same method of calculation, but here we are looking at when a liquid solute is dissolved in a liquid solvent to form a solution. And here we are looking at when a solid solute is dissolved in a liquid solvent to form a solution. Now the unit is the same. However, for volume, we can say that the unit of this is what? Percentage volume by volume, or percentage volume per volume. And here, the unit is percentage weight by weight, or percentage mass per mass. Okay, so generally the concept of concentration is the amount of solute in a solution. So for us to get percentage by mass, you have to know, if you are dealing with volume, you have to know volume of what? The solute over addition of volume of what? Solute and the volume of what? The solvent. Then because of percentage, you have to what? Multiply it by 100 over 1. This is also applicable for percentage composition by mass. But for mass, you will have to replace this volume with mass. You will have the mass of solute all over mass of solute plus mass of the solvent. So if you look at this thing holistically, you will be seeing solute over solution, because solute plus solvent makes up what? Solution. If you are given 6 grams of a salt, say magnesium tetraoxosulfate 6, and then you are asked to dissolve it in 250 cm cube of distilled water, then you should find the percentage composition. What you are going to do is, let me just express this thing. We are giving mass. We are giving mass of magnesium sulfate to be 6 grams, and then we are giving the volume of what? Water to be what? 250 cm cube. And then we are asked to find what? Percentage composition by mass of what? the solute, which is what? Magnesium what? Sulfate. This is what we are asked to find. Now, for us to find this thing, remember, you cannot work with mass and volume at the same time. What you do is, since the question is on the percentage composition by mass, what you are going to do is what? Find a way and convert this volume to give you equivalent value in mass. How do you do that? Knowing that the density of water is 1 gram per cm cube. This is exactly at 4 degrees Celsius, we know, but generally it is applicable for all calculations under this topic. Now, knowing this, and the formula for density is mass over what? Volume. Density is equal to what? Mass over what? Volume. What you are going to do is that you substitute density here and you replace it with 1. Then, given volume as 250, you obtain mass to be equal to what? 1 density times what? You are given 250 cm cube of water. So when you multiply this, your answer will give you what? 250 what? Gram of what? Water. 250 gram of what? Water. This is the mass we are going to be using. We will now place it in that formula that I initially gave us. Okay? Now, to solve this, you will have percentage composition by mass of the solute will be what? 6 gram of the solute, which was given to us, over what? 6 plus what is the actual mass of water here? 250. Then times 100 over 1. Now, when you multiply this, you have 600 over 256. When you divide this, you will have 2.34 what? Percent what? Weight by weight. Or you could say percent what? Mass per mass. This is your answer for this question. It means that there are that the percentage composition of magnesium tetraoxosulfate in 250 cm cube of distilled water is what? 2.34%. For you to obtain this thing in the lab, you have to dissolve 6 grams of the salt given in a volumetric flask of capacity graduated up to 250 cm cube. You will first of all introduce the 6 gram that you weighed from your weighing balance into the empty volumetric flask. Then pour a little bit water, then shake it until the salt has dissolved to some extent. Then you also have to fill the volumetric flask until the ring mark where you have obtained exactly 250 cm cube of that solution. By this, you have gotten the concentration of that particular salt, magnesium tetraoxosulfate salt. Okay, it will give you an approximate value of 2.34% weight by weight of magnesium tetraoxosulfate salt in that solution. All right. The next thing we are going to be looking at is when it involves liquid and liquid solute against a liquid solvent. For instance, you are given 10 cm cube of ethyl alcohol that dissolves in, say, 40 cm cube of distilled water. And then you are asked to find the percentage composition, by volume of the what? Ethyl alcohol. What you are going to do here is not different from what we have been doing before, which is what? The percentage is going to be what? The volume of what? Your ethyl alcohol over what? The same volume of what? Ethyl alcohol plus the volume of water times 100 over 1. So the percentage will be equal to 10 over 10 plus the volume of water given to us here is 40 cm cube times what? 100 over 1. Now what we are going to do is 10 times 100 will give you what? 1000 over what? This is what? 50. Now what do? Divide this. This will give you what? 20. So we have what? 20% what? Volume by volume of what? Your what? Ethyl alcohol. In practical, what you do is you have to what? Dissolve 10 cm cube of your ethyl alcohol in 40 cm cube of distilled water. What you have obtained is 20% volume by volume of ethyl alcohol in that solution. So it's as simple as that. So if you have any question, you can ask. Then let me give you one more question, which will involve solid solute and liquid solvent. Let's say you are asked to find out the mass of, let's say, sodium nitrate salt that will be required to obtain what? To obtain, let's say, 10% what? 10% what? Is it, let's say, weight by weight of what? The solution. In what? Let's say 100 cm cube of water. Now, some of you may go ahead and say, oh, since we can find out the molar mass of sodium nitrate, then you begin to use 23 plus 14 plus 3 times 16, that is around 85 gram per mole. Then some of you will say, okay, since we know we are given 10%, we are asked to what? Make it up to 10% weight by weight. Then 10% of 85 will now be 8.5. Then you will now have to what? Take 8.5 gram of the salt and then dissolve it up to what? 100 cm cube of water. No, that will be totally wrong, because when you have done this way, you obviously made the volume of the solvent negligible or arbitrary, which is going to give you a false positive what? Result. It looks like it is correct, but it is very wrong. How do you do this? This is a question under percentage composition. What you do is to what? provide yourself with what the method first, which is percentage equals to what the mass of the solute, in which case we are using sodium nitrate here, over what mass of the solute plus what mass of water, which is the solvent, times 100 over 1. What do you do there? Let us put our values. We have here mass of the solute is not given. This is the one we are actually asked to find. This is the one we're actually asked to find. Mass over the same mass plus what? What is the actual volume, mass of water given here? Remember what I taught you, that density of water is 1 gram per cm cube. So when you put 1 here, equal to what? The mass of water over, we are giving 100 cm cube of water. Then when you cross multiply, mass will now be equal to what? 1 times 100. Mass will now be equal to what? 100 gram. It means that 100 cm cube of water also represents 100 gram of water. So we are going to add 100 here, then times what? 100 over 1. The percentage we are giving here is what? 10. 10% from the question. So from here we can solve. So we have 100 times m. We give you 100 m all over, this will be m plus 100 times 1 remains the same, equal to what? 10% here. So we are going to cross multiply. So we have 100 m equal to 10 bracket m plus 100. So we have 100 m equal to 10 m plus 10 times 100 will give you 1000. So we are going to collect like terms here. We have 100 m. When this 10 m crosses the sign of equality, the invisible plus here will change to minus 10 m equal to 1000. So we have 90 m equal to what? 1000. So when you make m the subject of the formula by dividing both sides by its coefficients, which is 90, you have 1000 over what? 90. This will give you an approximate result of 11.11, which is the what? The mass of the sodium nitrate salt, which you are going to need to obtain what? 10% weight by weight or mass per mass what? Concentration of that same salt in what? 100 cm cube of water. So it means that in practical, you are going to weigh 11.11 gram of sodium nitrate, and then you place it inside a volumetric flask graduated to what? 100 cm cube. Then when you dissolve it with little amount of water, then you have to what? Fill it up to the ring mark, up to where it is graduated to be what? 100 cm cube. At this point, you have gotten the actual concentration of what? This particular salt, which is what? 10% mass per mass of what? Sodium nitrate in 100 cm cube of water. I hope you enjoyed this class.